Welcome back, everyone. We are back with another session by Mihail Mateev on Azure Digital Twins in a nutshell. Mihail Mateev is from Bulgaria. He's also an regional director, Microsoft regional director honorary, and holds an MVP on Azure data. He also holds a PhD in cloud computing with broad expertise in Microsoft technologies, various Microsoft technologies. He's also a community enthusiast who delivers and also organizes various community events like Data Platform Geeks. So without any further delay, let's begin with the session. The floor is yours, Mail. Thank you for taking your time. And thank you so much for taking time out from your schedule to deliver a session for the Data Platform Geeks community.
Thank you very much for the introduction. Hello, everyone, and welcome to this session on Azure Digital Twins in a nutshell. Hope you will enjoy this session, which I prepared pretty soon with some updates related to the latest preview of Azure Digital Twins service. We have the following agenda. Probably not everyone from you is aware about digital twins concept, so I will explain some things around digital twins concept, and we will go deeper into digital twins for IoT projects. We'll have some comparison between different implementation around digital twins, because we have digital twin service in Azure, but also we have device twins, for example, in IoT, which is simplified version. We will have some comparison also across different cloud vendors to see that really Azure Digital Twin service is the only one offering out of the box software as a service digital twins functionalities. And we will have also some details around digital twin service preview versions. The previous one is from 2018 and the latest one from 2020. And we will discuss some specifics around this implementation, especially for Azure, and hope we will have time for some nice demos. This is the general agenda, and let's go ahead with some details around digital twins history. Digital twins, sorry?
So sorry to interrupt. I don't think you're sharing your screen right now.
Probably you're right. Okay, thank you for this.
Yes, now it's perfect.
Yeah, thank you very much. So, digital twin is nearly 20 years old, like concept. Actually, the first proposal is from 2002, and it is more related to modeling of solutions related to product lifecycle management. The idea comes from one research from Dr. Michael Greaves, and it is related exactly to proposal to have twins digital replica of some solution which actually is a software solution. But in digital twins history, we mostly relate digital twins to replica for physical solutions, for physical objects, products, structures, more complicated or more simple. But in general, you can have digital twins like approach where you can have digital replica of both physical solutions different kind of physical systems like machines and structures, and also software systems and solutions representing different processes. Step by step, digital twins stay more popular in different industries, including aerospace, and latest several years it stay more and more popular also for Internet of Things. There are several uh, general concepts which is good to know before to continue. When we talk about digital twins, like concept in general, you can see several specific terms like digital twins prototype, digital twins instance, digital twins aggregate. The idea is that we can use digital twins like approach in several different ways. When we consider digital twin prototype, that means we have a digital replica, but it is still for prototyping and modeling before the real solution to be created. It is usually in the uh, moment when we have design phase. We have digital twins instance, which is typical for maintenance and implementation period when we have solution in production and we have digital twins like replica, which is used actually to synchronize changes from the original solution, to make some analysis over it, to change the configuration, and to push back this configuration to the original system. Doesn't matter if original so-named system is physical or virtual. And we have also term digital twin aggregate, which is considered like representation as common aggregation of several physical instances. Often we have cases where we need to have some aggregated data and to make analysis over this aggregated data, so we can have one digital replica of several physical or virtual instances and to implement some aggregation and analysis over these aggregated data at real time during the maintenance period. What we need to know additionally. Digital twins is a concept which covers many other proposal solutions for design and for simulation, but it is much more than each of these solutions because we have here several functionalities together, and we can have this concept quite applicable for design, for research, for simulations, for maintenance and analysis, for product development. It is something which stay very wide like areas of application, and we can do it in different business domains. Also, it is good to know that around Internet of Things and artificial intelligence, really we have additional grow with digital twins concept. This is something which comes together with staying more and more popular Internet of Things and artificial intelligence and different analysis around AI, because as you can see a little bit later, we can have digital twins also as integration layer between original solutions and different services used for analysis. So this is something which really help us to apply more formal different uh, analysis on specific physical and virtual solutions. You have using this approach counterpart of the original object, and this counterpart is very applicable for different analysis and changes in configuration. So this is something which really you can reuse for different purposes. In which areas we have digital twins probably more often used? Again, I would try to say that digital twins covers almost all areas for our real life. Initially, it was more considered for different industry domains because we are able to have modeling and analysis for different machines, for structures, and we are able also to use this approach for energy area, for example, for simulation of processes and optimization for energy models. But step by step, this approach can be applied in almost any area, including healthcare, including fintech, almost everything. It is good to start with samples around industry because in industry you can have more often already implemented solutions which you can relate to this technology. So probably one of the first areas where digital twins was introduced is around buildings and structures, because you are able to provide different analysis. Here you are able to have analysis of complex structures around mechanics. You also are able to provide health monitoring of structures, not only structures, but we are talking here mostly about this. We are able also to provide testing of different materials and components which are applicable for this industry. We can see here on this schema actually the approach where we have some real system from real world, and we have some replica where we can actually experiment or analyze with different settings. But considering exactly this approach, we can go even a little bit further and to consider digital twins also for areas related to sales and marketing, because when one dealer of some machines or some products actually sell this solution to some customers using this technology, it is possible later to have continuous maintenance for already sold solutions, to provide support maintenance, bug fixing if it is software solution, or repairing using approaches like predictive maintenance. So in any case, you are able to have a very high business value, added value, when you are using digital twins concept for maintenance of different kind of solutions. Of course, it is important to have the proper modeling for your original solutions, because complex models, of course, have much more complex and more expensive maintenance and support, even on the context of digital twins implementation. We can have digital twins, as I already explained, on the middle between some connected products and different services for analysis. We need this because usually services for analysis should have no idea about the real physical solution. We just solving some cases with analytics services, and we need to have exposed in a proper way model via appropriate integration layer between these analysis services and connected products. So in this case, Digital Twins platform also is quite convenient. This is something which you can see in many already implemented solutions. It is one of the most popular approaches. Let's see also what is the slight difference between modeling, simulations, and digital twins concept. Probably this is something which is good to be clarified, because quite often many people say, well, it is something which is not pretty new. We are using different approaches for modeling of different products, structures, and to provide some simulations. It is something which just partially covered everything around digital twins concept, and exactly this is something which is good to be clarified. So usually we have simulations where we have very similar things like sensors, sensor data, and simulations which generate and manipulate data as part of the simulation actually. But when we have digital twins, we have actually bidirectional sync. So it is not something which actually just generate some artificial load to be possible to see the behavior of some model. Here we can have bidirectional solutions, so we are able to have from one side simulated load for the replica, but we can get also information from the real solution, and we are able to push back to the real solution because we have a bidirectional communication, some changes in the settings to be possible after analysis, which we have to configure at real time often the original solution to perform better. Another concept is related to modeling, and I will provide you an example mostly with construction, because construction is one of areas where hopefully I can say that have expertise. It is one of the business domains where I work from probably 25 years. So in building industry and construction, there is modeling approach using so-named BIM, Building Information Modeling. And it is something which is focused on modeling of complex structures. You can see very similar things like very detailed modeling of structure with materials, connections, even behavior. But again, it is something which is used mostly on the design phase, and it is possible to be reused again for the design phase, but it is not considered to be continuously used during the exploitation life cycle. Nowadays, using digital twins, it is possible to have advantages of both technology at the same place. So we are able to use different user interface to have modeling, but modeling should not be related only to closed solution around some industrial standard. We can have a modeling approach based on digital twins, and we are able to have simulation, and we are able after that to have during the life cycle maintenance of these solutions. So this is probably the more specific, which give us advantage around digital twins to have something more plus already existing approaches for modeling, simulation, and analysis. When we talk about IoT projects, this is the place where probably during the last several years, we have one of the highest impacts based on digital twins. This is exactly because this technology gives us options from one side to be integration layer between different connected devices or systems and backend services. From another hand, it brings option to have common data model, something which is very important for Internet of Things. In general, IoT for me is much more related to data platform than probably other groups of technologies, because all these solutions are data centric. And we are able also to have very specific functionalities for connected devices, like software update, like device provisioning, pretty easy compared to traditional approaches using digital twins. So that's the reason to have a little bit more on IoT content in this presentation. Another case is that probably also there will be some discussions why we need digital twins to manage devices when we are able to do this without specific platform, without specific solution focused on modeling of our original systems. Yes, it is possible when you have some changes in your devices to have custom, not related to specific general approach implementation, where based on changes in your devices, we can send some messages. These messages can be able to be processed to write some logic, to have some commands back to devices, and to manage in this way the whole solution. The specific thing is that using this approach, you will have a very high complexity of similar solution, and it will be much better if we are able to have one platform focused mostly on this, to have digital replica of the original systems and to be responsible for representation of any changes, rising of some events, and possibly integration with other services. More important, of course, about analytics services. It is something which you can do with digital twins. Around IoT, the first implementation, which is well known, is related to the state of connected devices, sensors, and more complex devices. This is something which is very important for Internet of Things solutions. We need to have configurations of the devices, their actual state available somewhere, and we can have a configuration which is so named desired configuration, the state of devices with different settings, which is planned to be reached after some changes, reconfiguration, software update, or some other activities. In Azure IoT Hub, you can see this exactly in registry of devices. In each IoT hub, we have such kind of implementations where we have simplified version of digital twins, so named device twins. Device twins is used to be possible to synchronize configurations. So you have from the back office some settings which actually are represented with desired configuration. This configuration should be reached from devices. This desired configuration is pushed from the backend to device registry, and at the same place, devices are sending their current configuration, and periodically devices are checking for updated desired configuration. If there are some differences, there could be logic to try to make the same current configuration compared to the desired, and from the backend also is possible to read the actual configuration of devices to push new updates using device twins, or if it is needed for specific purposes, it is possible to be enforced directly with direct commands to devices. So this is something which can be seen in many places. It is very popular for IoT, and it is one of the first places where where digital twins concept is implemented for Internet of Things solutions. Nowadays, we have in second preview Azure Digital Twins service, which is something slightly different, covering all these functionalities, but much more powerful. This is probably the only one service available now on the market for common purpose, available for everyone, like software as a service. There could be found some solutions which are specific for specific business domains, for specific solutions, but these implementations are usually very specific, related to some business case, or on a price which is not accessible for independent vendors, small companies. So really, Azure Digital Twins service is a game changer in modern industry, making available this concept out of the box for different vendors for implementation and usage. And it is possible, based on spatial intelligence graph, to have quite complex models, to have modeling of everything which we have from the real world. Just we need to have the right experience and right sense how to model the original solutions. It is possible to actually collect information and have the state of devices. Digital twins work very tightly connected with IoT Hub. We will see a little bit later. The first preview had IoT Hub inside, but nowadays IoT Hub is decoupled to be possible to have more flexibility. One of the most important things, really, at least related to my experience in Internet of Things, is a very good support of role-based access control and multi-tenancy. in the real world, when we have big IoT solutions, especially for enterprise companies, which provides solutions for other companies, other clients, enterprise clients, and several layers of customers could be available, plus end users. So we have complex B2B and B2C implementation. In such kind of solutions, we are able to have quite complex cases related to multi-tenancy for different organizations, sometimes with matrix structure, and also it affects the role-based access control, which is with high complexity sometimes. Digital twins is probably the best approach when you want easy to implement these for Internet of Things solutions. So really, regarding to my experience, I appreciate it very high. And of course, integration options for digital twins service. From one side, this service has option to configure endpoints for output and input, and it is possible also to raise events and to call Azure functions, to call also not especially Azure functions, but any kind of endpoint with HTTP request. So this is something which is good to be clarified. It is good also to make difference between device twins, like very simple version of digital twins, like I already explained, and digital twins service like common platform, very powerful for very different cases which can be used. So let's just add few details about device twins. When we have device twins, as already described, it is just twin of JSON structures where we have two different configurations, more complex or less complex, but two configurations. Another case which is good to be clarified is what we have on the market, like digital twins supported platforms. You can see many materials covering this topic, and in general, many vendors explain that they support this. It is not exactly true, because the only one service which really works out of the box and needs only configuration but not additional custom development is Azure Digital Twins service. For other platforms, we have just different services covering specific functionalities which are included in the whole concept, and you need to have custom development and configuration to integrate all these services. So it is not so easy, it is not so straightforward, and you have some time to market to be possible to implement this solution. So in other platforms like GCP or AWS, it needs custom development, and it will take time. You can also see terms IoT device shadows. It is actually the same analog like device twins from AWS, which is focused on device configurations, covering few more specific things, but in general, it is device configuration. It is not something which can cover complex scenarios. Regarding to complex scenarios, in AWS, we have again no platform, no common platform. You can have modeling with specific service like Amazon Cimmerian, for example. You can use their IoT services. You are able to use their analysis services like Amazon SageMaker, but you have just set of services. You need to put a lot of effort to have real digital twins based solution. So this is the main difference when we consider different platforms. And it is also good that Microsoft offers two different implementations. For the most often use case, especially for IoT, we have integrated solution with device twins for IoT Hub, and we have digital twins like common platform which can be used for any kind of scenario. Here we have on the schema just a comparison between Azure and Amazon gateway services with device twins and device shadows. You can see that they have pretty similar functionalities. Another important thing is that digital twins is related to Industry 4 and Industry 4.1. Probably you are quite aware with this, but I will try to add some small additional information. Usually we consider Industry 4 when we have automated production process with smart logic inside it. Industry 4.1 actually considers the same, but when it is possible to do it in easy way. That means user-friendly. This is something which is related to technologies like, for example, power-ups, low-code platforms, which can be used for simple implementation, for some additional functionalities. Azure Digital Twins service, like software which offers digital twins as a service, and where using such kind of technologies, not only this, but these are one of the technologies which are used, we are able to have one easy way to automate our industrial production processes. Before to have demos, I will give you some insights about digital twins service from the beginning and changes which are done this year. Still, you have information worldwide available in documentation for both services, but preview from 2018 will be retired at the end of this year. So it is good just to consider some differences to be possible to recognize solutions and to not consider some old concepts like the actual one. I can say that first preview has most of the important things which we need for digital twins, with some specifics that actually IoT Hub was integrated inside digital twins. Scaling integration with compute was not so easy and simple like for the latest preview. And about modeling, there was a concept based on smart spaces. It started with buildings and smart management of spaces. So you always started with set of preset spaces plus options to create your own objects for your solutions. So having this conceptual technology slice, you see that we have digital twins in the previous preview, as I mentioned, on top of IoT Hub, but and some already preset um, classes which can be used for our models, and you are able to use also vertical solutions. Some of IoT solutions accelerators was based on digital twins, and you are able to use Azure IoT Central with Azure Digital Twins. Considering the whole Azure IoT blueprint, you can see that digital twins can be used in several places, in several subsystems for IoT, which is probably interesting and very powerful. Of course, one of the first things is simulation and visualization, which you see here. But it is just a small part of what we can have. Cloud Gateway, which is actually the service in front of other services for IoT solutions, represented usually for Microsoft Azure with Azure IoT Hub, is also a place which is tightly related to digital twins. During the first preview, actually digital twins was on top, so you were able here to put directly digital twins or to use it separately with some connection in between. Nowadays, for the latest preview, you have only one option to use digital twins connected to IoT Hub, but not directly to use it like a gateway service. So it is good to be clarified. Additionally, you have integration, digital twins like integration service with any other business solutions. And one very important thing is common data model. Common data model is something which we need to have in IoT solutions, especially in big IoT solutions. And common data model is probably the heart of so-named device configuration management, the subpart of IoT solutions which is related to configuration, maintenance of devices, software update, device provisioning. So we have all these functionalities here. And again, I give you a remind, nowadays, digital twins is not used directly like gateway service. In the latest preview, we have several improvements. Flexible modeling, one of the very important things, especially for me. You are able to have digital twins definition language, or so named DTDL. We will see a little bit later this. And based on this language, you can have modeling of almost everything in a more formal way. In the previous preview, we had some ready for use in your model subjects, and you needed to define a little bit more difficult additional custom objects which you needed for many cases. More flexible topology. Now you can have quite complex relationship between models, and you have no any problems to do this using device twins definition language. So actually we have this relation between modeling approach and topology. And we can now easier and simpler to integrate compute in the context of calling endpoints with from Digital Twins service. We are able also to have event routing where we are able to actually in a common way manage different events based on the common logic and to rise different events on the solution level to call other services to have actually the full lifecycle management. We have also better approach for integration and management with IoT Hub. Why? Because now IoT Hub is separated and you have access to all functionalities. In the first preview, IoT Hub was actually a core part of Digital Twins, but you are not able to control some of settings. So integration was preset and was not so flexible. We have, just a second, security approach, which is equal with other Azure services. The small difference is that the previous preview, there were some specifics, a little bit different user experience when you implement security, and scalability, especially related to computing, is much, much better. There are, of course, some limitations because when you provide some software as a service, you need to prevent this service from overload for some attacks, some vulnerabilities, and there should be approach where we have some kind of throttling to have, or another approach to, but based on limitation of specific metrics. Otherwise, it will be not possible to implement such kind of complex solution as software as a service. About functional limitations, how many objects you can have, how many relationships, and some other things, you can see device in the documentation. Our presentation is limited by time, so probably we will be not able to go in these details. It is possible to configure input and output endpoints in relative easy way, but even for services for which you have no option for direct integration, you can do this with, for example, Azure Functions. So we have options to integrate in these ways, like some service in between, like or Azure Functions, Azure Digital Twins with almost everything. This is actually a high-level presentation of what I explained. We have also more powerful UI tool for free. In production companies, often for digital twins is used specific UI to be possible to make easy modeling. There are similar implementation from Bentley and their products. There are implementations from ANSYS, for example, but you can get for free so-named Digital Twins Explorer, which is a pretty good tool, web-based, based on Node.js and JavaScript with React. You are able to import models, change models, download models, manage models. So you can start using these tools pretty easy to make some modeling activities. Of course, you can do this with custom client where you will add logic how to create your models. Let's see several real-life cases which we have with digital twins before to continue with demos. First one is typical from the initial concept with smart spaces. In this case, we have solution which measure metrics in different rooms, and based on temperature, humidity, and other parameters, actually sends information and alarms that there should be changed in the specific air conditioning or to be done some other changes in configuration. So here you see digital twins also like part of our front-end service or gateway service. And you can see separately IoT Hub, which again can work with digital twins, but with very complex flow. One of the important things is routing. Routing gives us options to have different logic when we have collecting of events from digital twins. Nowadays, the most popular use case is when we have digital twins connected via Azure Functions with IoT Hub. It could be, of course, with any other cloud gateway service. Just with IoT Hub, it could be even directly, but more general approach is with Azure Functions, and we can have ingress and egress services out of the box. How it works when we have root events? Imagine that you have your representation of the real solution in digital twins model. If something is changed, so we have from the input some data which continuously is changed, and if some parameters are changed and we have specific, for example, values in some properties, events can be raised, and we have common flow where we can actually collect events and dispatch events regarding to specific needs in our solutions. Based on each flow, we can raise some logic which can update the model and the original system. This is probably the more general approach which works for almost everything. We can see in the demos also samples where it is possible to have using simulated device and Azure functions update of some properties of parts of the model, like for example some sensor, and based on this, on the output to get the event and to change the configuration. Modeling is based on JSON-based definition language, DTD, Digital Twins definition language, and you have several required things here. You need to declare what type of model you have here, because we have several different types. We need to clarify the context. We need also to define the namespace. So in this way, is possible to have actually a fully functional configurational management system. Another real-world solution is when we have, as I already explained, for common data model, part of device configuration management system, digital twins. We had similar solutions in practice. So probably another interesting model, which we did even with the first version of Digital Twins Preview, is for predictive maintenance. We have a solution where Azure Digital Twins service is integrated with cognitive services and the relative new anomaly detector to be possible to detect some not expected behaviors and to write some logic. So it is something which represents the power of IoT using Azure Digital Twins and cognitive services to provide predictive maintenance. This solution pretty soon will be updated with the latest version of Digital Twins service. Just one schema with the old concept around smart spaces for Digital Twins when it was in the past, as I already explained, and the new approaches where you have absolutely flexible custom modeling. For the older versions, we had also UI tool named Graph Viewer, which is much less flexible like than ADT Explorer, which we already mentioned. Now we are able to sorry go ahead with several demos where you will see how actually we define the spatial model. So I will switch to my Visual Studio. Let's check if it is shared. Yes, it is shared. Perfect. So you are able to start with samples based on what you can find for free in GitHub, like base samples for Azure Digital Twin service. Again, you need to consider that you can find samples still for both the latest version and the previous one. It could be a little bit confusing if you do not know this, but if you already have this information, I suppose you will be able easy to recognize which one is the actual solution. So I will try to show you first. Let's try to make the size bigger. How we can create Digital Twins service. So Digital Twins service is available in in the portal. Nowadays, you already cannot create instances of the deprecated old version of Digital Twins service. I will show you a little bit later what is the difference. You need to choose as for any other service, of course, subscription. You need to select also standard parameters like resource group. You are able already to have a resource model for this. You can choose the right region. Not all regions are still available. And data platform gigs demo will be the name of my service. So you can add, if it is needed, tags for some provisioning purposes, and that's all. And you can just create this service. Because creation of service sometimes take few minutes, I will try to show you actually already created several services. Here you can see that for digital twin service you have actually two digital twin service preview, the actual one, and digital twins deprecated. So let's consider that we are focused on these services here. The new one, which you see here, is already created, but I already created one which is configured. It is good to know some details about this. First one is related to access control. Access control looks like typical access control for many other services in Azure, but there are some specifics. For many operations, you need to consider one additional role, which you can see here, so named Digital Twins, Azure Digital Twins owner in brackets preview. It is different than owner, which we have like owner of specific resource. And to be able to make some operations, like for example, editing of models from different applications which need to be authenticated, you need to have for your authentication, for some functionalities, role of Azure Digital Twins owner. This is one of the things which you need to know in advance, and we have actually here almost standard things which you are able to find for other services. You are able to create also from here endpoints, or to create these endpoints based on the ASD key. But yes, it is possible to configure it even just with this UI. What is important regarding to our configurations, all permissions here should be used with registered applications. So if we go back to our main screen and go to Azure Active Directory, I already prepared several application registrations which can be used for this purpose. And for example, this one already created with specific parameters like application ID, our tenant or Active Directory ID, and here we need to consider what kind of permissions for API we can provide. It is very important to have from APIs. I already added it, but in general, Azure Digital Twins, again, it is already added, and you need to have read-write access if you want to be able to manage the models. Another thing which is important in this case is to configure also some details around authentication. You need to add, depending on what kind of application you will use to connect to digital twin service, the specific supported application types. So let's now just first go to the first example. In the first example, I will show you pretty simple client application, which is used to work with API. Oh, give me a second. Yes. When application is started, any kind of application which is using the SDK. SDK is wrapper around REST API, of course, used here. You need to have, in the current case, option to register with specific credentials. So token is returned and our application, if of course I didn't reach timeout, sometimes it is possible to reach timeout, already our application is authenticated. Initially, you can start with samples where you can see with help what kind of base functionalities you have. You are able to create models. You are able to create digital twin instances. You are able to create relationships between different models, and you are able to also define event routes. So in this way, you can actually do everything which is available with API. Just you can start in an easy way. But probably it's more interesting, because we have not much time, to show you what we can do with let's just change the browser, because I have several different configurations. Apologize for this. I will show you now. Just a second. Already pre-configured Digital Twins Explorer, where I already loaded some models, but I loaded one pretty simple model already created. When you run specific query, if your token is not expired, you can download whatever you have from Digital Twin service. But the most important is that here you are able to load models. And when we want to load model, then I will show you now how we are able actually to load several different models. Let's consider this folder of the just here. Yes, this is my mistake, and I will be able to show you based on this digital twins definition language how looks this model in general. This is something like this. You can have some base definitions which you are able after that to extend. But let's now try to load these models. I'm loading all these models. The case is that I already have some of models loaded in these applications, and duplication arise this error. Now I will try to refresh. We're almost done with this. I will load now models. Again, just these models are loaded, and I will try to load also some digital twins solution model, which is usually more complex model. We just use definitions in these simple DTDL files. Let's show you in advance. First, I will load it because it's easier. For example, this sample with electrical grid. And if we go to our sample, here I will show you again how it looks. So this is just Excel spreadsheet which contains different already defined via DTDL objects and relationship in between. So you are able to use this approach to load pretty easy such kinds of solution. You are able to save this model into Azure Digital Twins service because initially it is loaded in the client, and after that you are able to edit it. You see import is successful. We can make some queries and we are able to make also some changes in our components of the model. So unfortunately, we have not much time. So it was probably the most important, which I succeeded to show you. And thank you for attention. If you have any questions, I will be glad to answer. Feel free to contact me after the event also in social networks or to write me. I will provide all information around this presentation and samples via this virtual symposium organizers. So in any case, you will have all information available. And if you are curious about some specifics or if you need to have more deeper discussions about digital twins concept and especially Azure Digital Twins, feel free to contact me. I will be glad to have a discussion. Thank you very much and enjoy the conference.
Wonderful. Thank you so much, Mihail, for that very insightful session and those wonderful demos. So we can just wait for 2 minutes for the audience to post their questions in the Q&A panel. Friends, please, if you have any questions regarding this session, you can use the Q&A panel where Mihail can take up the questions. And Mihail, interestingly, you're also delivering the session at DPS this year, the DPS Data Platform Virtual Summit. Do you have any words about what you are going to speak? Just a quick gist for the audience.
Well, usually I like to speak on several actually different areas. One of the areas is around digital twins, as already you saw. Another area is around Power BI embedded analytics. And also I like a lot to have mix between Power BI, Cosmos DB, IoT. So I usually enjoy presentations covering data platform mostly in the context of Power BI and Cosmos DB, and also mixed reality like Azure Digital Twins. So I think that I will provide some interesting information for attendees in this context in Data Platform Summit, really.
Great. Thank you so much, Mihail. I don't think we have any questions right now, but like you said, the attendees, please reach out to Mihail post the event, and he will be happy to answer your questions.
Thank you very much.
Thank you, Mihail. The community is grateful for your session. Thank you.
Thank you. Bye.